Hello, pre-algebra class. Welcome to another episode of Mr. Chow Time. This is for scale drawings and models. Lesson 8, page 225. So, scale models and scale drawings. What are those? Well, it's a representation of an object that is too big or too small to be drawn or built at actual size. So, an example of this is the world. You cannot make the world, and so you make a globe, right? You know, one of these things that you see in some classrooms, and it's like, oh yeah, this is how we know how big Taiwan is compared to China, and here's Japan, and so here's the world, and yeah, this is a globe, which is a scale model of the Earth. The dimensions, which is things like the length, the width, the height, are proportional to the actual object. So if we were looking at a real house and then a toy of that house, the height would be proportional to the width, and so on. Scale is the ratio of a given dimension on the drawing or the model to the corresponding dimension. So for example, if 1 inch on the drawing of a map, let's say we're looking at a map of Kaohsiung, 1 inch on the map is 3 kilometers, then the scale is 1 inch, 3 kilometers. So here's an example. Let's say we have a model of Saitama, and that the fist on Saitama has a length of 3 centimeters. And if the length of Saitama's actual fist, the fist is, this right here, this is the fist, is 9.5 centimeters, then what is the scale of the model? Well, the model, the fist is 3 centimeters. And in real life, it's 9.5 centimeters. So the scale would be 1 centimeter on the model was how much of the actual fist. So we could cross multiply. That would give us 3x. And then we can cross multiply in this direction, and this would be 9.5. And then we would divide both sides by 3. And x would be 3.16 something something something. So we'll just stop there. So the scale of the model is 1 to 3.16. So this is very similar to finding like a unit rate, but not exactly. Because in a unit rate, the bottom is 1, and also the units are different. But here we're talking about sometimes the same thing, sometimes not the same thing. So your turn. Let's say that Skylar is building a model bridge for his model of San Francisco, which he's building in his room. The length of the model bridge is 16 centimeters. The actual bridge is 50 meters. So what is the scale of the model? Welcome back. Okay. I think there's actually another slide here that gives me some space to draw. There we go. Okay. So the bridge is 16 centimeters, and in real life it's 50 meters. So we want it to be 1 centimeter over some amount of meters, right? So that's 50 equals 16x. Divide 16 by both sides, and this will be 3 3 is 30, 42. 42 minus 50 is 8. 8 over 16. Is that right? So that's 3 and 1/8. No, 1/2. 3 and 1/2. So it's 3. Oops. Wait a second now. 16 times 3 is 48. 48. 48 is 2/16, so this is 1/8. Okay. 3 and 1/8. Over 1, right? Because 3 and 1/8 is x. So 1 centimeter is 3 and 1/8 meters. This is our scale. Okay. A note on scales. If the scale drawing or the scale model and the actual thing have the same unit of measure, then the scale can be written without units. This is called a scale factor. So suppose a scale model has a scale of 1 inch to every 2 feet. So 1 inch is equal to 2 feet. Right, so this is our scale. Well, 1 inch is equal, 2 feet is equal to 24 inches. So because both of these have the same unit of measure, we don't have to write that. We can just write 1 to 24. For example, let's say that Kathy has a blueprint of a skateboard ramp that she likes to use. And the blueprint in the drawing is 11.4 inches. And the scale is 1 inch for every 6 feet. So what is the length of the actual skateboard ramp? Well, instead of 1 inch to 6 feet, we could say that 1 inch is equal to 6 times 12, which is 12 and 7, 72. So 1 to 72. So then we would just take 11.4 and multiply it by 72. And what is that? I have no idea. And so I'm just going to, I don't have my calculator. I guess I'll just use my computer calculator. (11.4 times 72) is 820.8. 820.8 inches. This is the length of the actual skateboard ramp. Okay. Another your turn. No, this is your turn. Sorry. A map of the infamous hidden room at KAS shows that the room is 7.25 inches wide on the drawing. If the scale of the map is 1 to 8 feet, 1 inch to 8 feet, what is the width of the actual hidden room? Welcome back. Okay, so this is another one where we can convert this to all inches first, right? So 1 inch equals 8 feet times 12. So this is 16, 96. 1 inch to every 96 inches. So 1 to 96. And then it's 7.25. So 7.25 times 96 equals something. Let's figure it out here with a calculator. 7.25 times 96 is 696. 696. So the width of the actual hidden room is 696 inches. Okay, moving right along. Let's say that we want to construct some scale drawings. To construct a scale drawing on an object, use the actual measurement of the object and the scale to which the object is being drawn. So let's say that Victor is painting the mural next to the science classroom wall. And the science classroom wall is 18 feet long and 12 feet tall. So you're going to make a scale drawing of the mural. Use a scale of 1/4 inch equals 3 feet. And so we're going to use grid paper that has 1/4 inch. And you have 1/4 inch grid paper because I gave it to you. The paper that I gave you, the notebooks, have grid paper, right? And each one of these boxes is 1/4 of an inch. So that's going to be our scale. 1/4 inch is equal to 3 feet, right? So this is going to be 3 feet, 6 feet, and then another 6 feet. So this is going to be 12 feet, right? And then it's going to be 18 feet long. 18 feet goes into 3 6 times. So 1, 2, 3, 4, 5, 6. So this is 18 feet. Oh no, I don't want to use this. Let's use the line tool. So that means Victor's mural is going to be contained within this box. And if I know Victor, he is going to make a mural of a cube. Okay. Your turn. Let's say that Harry is designing a courtyard for the school. The courtyard is that area between all the classrooms, you know, with the wood where you guys hang out sometimes. And let's say that it's 45 feet long and 30 feet wide. So we're going to make a scale drawing of the courtyard, and we're going to use a scale of 1/2 inch is equal to 10 feet. And we're going to continue to use that 1/4 inch grid paper. So if every 2 boxes is 10 feet, and it's going to be 45 by 30, so let's do the 30 feet first. 10, 20, 30, right? So this is 30 feet, 10, 20, 30, 45. 45 feet. So this courtyard that Harry's making is going to be this big. Now, there's no way for me to check to see if you've done this in the Edpuzzle, so I'm just gonna assume that you did. All right. Your must do. It's 227 to 228 odd. Have a good one.